Evening, sir.
Yeah, hello, good evening. I'll start, okay? So, give me 2 minutes. Okay. Is screen visible?
Sir,
Yes.
hello.
Yeah, hello.
Sir, your voice is very low, sir.
Uh, Voice is very low.
Yes, sir.
Mm,
Sir, not able to properly.
Increasing my. Okay. Give me a minute. Hello. Yeah, I think I don't know. Increasing my voice will not make any difference, right? So, okay, is it better?
Yes, sir. Yes, sir.
Okay,
Sir, I
increasing.
have a question, sir.
Yeah,
Sir, for quiz 2, syllabus will be from week 5 to week 8, or it will be from
week
week 1
5 to
to
week 8.
week 5?
Yes, yes, week 5 to
Week
week 8.
5 to week 8 for quiz
So
2.
nothing
And
from week 1 to week 4. 4.
yeah, nothing from week 1 to.
Sir, but in instructions it was written, sir, week 1 to week 8.
Which instruction?
Sir, in our manual, sir, in our portal, it was visible, sir. Week 1 to week 8.
Grading document.
Yeah. In the graded options, it is written, sir, week 1 to week 8, sir. That's why I'm a
Mm,
bit confused.
Yeah, and the maths instructor also told that in maths from week 1 to week 8 it will
yeah,
come.
but in stats it's week 5 to week 8.
And actually I saw a few PYQs also. There is nothing to like to stress about. There are few questions only from the week 1 or week 2 and they are easy.
Yes, but this time it's changed. This time only week 5 to week 8. Um, this is the syllabus given here. Mm, was 2. I mean, do they give quiz to syllabus here in grading document? I don't I don't see anywhere, right?
Sir, in the portal, sir, in admission section, it is given.
Portal admission.
Yeah, sir, did not this one. If you log out, you will get the IIT Madras online main portal. There, sir, a syllabus is given in admission column.
Sir, in student handbook also there it is there, but I don't
Yeah.
know if it's updated. The student handbook.
Okay. In student handbook as well. Where is handbook? Okay, this one. But it is week 5 to week 8. That's for sure. So you're saying in uh,
Sir, is that for only statistics or for all the other
Yes, sir,
subjects?
for
in
statistics. I can say for statistics. For other course, I can't say. So yeah, whatever. Okay, so it's week 5 to week 8 only in in this quiz too.
For statistics, it is from
Yes,
week
yes.
5.
For statistics, yes. Okay. Okay, so we can start. So you know how to join. Search joinpd.com, probably through mobile, and type this code. Yeah, week 5 to week 8. Okay, so no doubt there in stats one. So today's session will be solved with us. We'll do questions on week 7 probability, and okay, how many 20 joined? What about others?
They are in CT, I think.
Okay. What about others who joined here? 78 participants, right? So only 23 connected.
So please wait, I'm also trying.
Yeah. 25, 26. Okay. Okay, so we'll move forward. The code will appear at the right topmost. This code, right? Now you are familiar with this, so it will appear there, and website is same.
So please
joinpd.com.
wait for a second.
Okay. We'll wait 2 minutes. Okay, that's all. We'll start at 15.
Yes, Sajjan.
Okay. Let's start. Okay, so this is top rightmost. Code will appear if anybody left to join fast. Okay, first few slides, you know how to join, how to give an answer. So, okay, what is this random experiment was, so this, like, we already covered all of this, but can just go through this. Random experiment is experiment whose outcome is not predictable, right? So there will be outcome, but just not predictable. Then sample space will contain all the possible outcomes of a random experiment. Event is a some subset of sample space, and it will contain some outcomes, some uh, some probable outcome, some possible outcome inside a event. So that is what event is. Then for any two events, A and B, so yeah, if all the outcomes in A are also in B, so basically event is a subset of space, sample space. So all the uh, it's just a smaller version of the bigger portion, right? That's what subsets are. Okay. Okay, so this is the first question. You can maybe submit it, right? Uh, Yeah, okay, two responses. How much should I give? Uh, okay, let's have 1 minute. We'll move. It was very easy. Okay, 42, and okay, the time is up. So okay, the question is, these are the following experiments. You have to say that which one is a random experiment, right? So selecting a family out of a given groups of family. So it's like a selecting out of something n things. You have to select one. So it's a random experiment, right? Any family can come out. Uh, so that's a random experiment. Selecting a card from pack of uh, that's like very easy. That's what if you have seen a lecture or something, everywhere it's being explained that picking card from a deck is a random experiment. Then rolling a die and noting down number on the surface. That's what we do, right? When we roll a die. So all three are random experiments.
So,
Yes.
for example, in option A, this consider the following selecting a family out of a given group of families. If we just would have put some category over it, then it wouldn't have been random, right?
If you have put a what category?
Category, for example, a family with only 4 members or 3 members.
No, still it's a random experiment. So then we are selecting. Let's say then your data would be like you know. I think I think let's say your data would be like, let's say five people, 6 people, 7 people, 4 people, three, two, all would be there, right? Different varieties of families will be there, and you have to pick one. So picking one is a let's say picking one with a five family. So how many are this this types? That's what it is. So it's still a random experiment. I mean, so basically what you are saying is, let's say rolling a die, right? So that outcome is 1, 2, 3, 4, 5, 6, right? You are saying what is the probability or what is the event of getting a three. So that's what you are taking one out of that. Now the sample space is different than here. Here it's just a simple sample space. Families are there, and you have to pick out something. But if you are looking at numbers now, then that's how your sample space will look like, right? With numbers. Okay.
Okay.
Okay. So yeah, all the above are correct. Okay. Next question. Mhm. Okay. I think somewhat calculation is required. Let's give 3 minutes. We'll get three.
Sir, your audio is not coming.
Sir, you are not audible.
We
Sir,
can't
your
hear
voice
you.
is not audible.
Okay. Sorry. So I was just saying that we have 2 dice, and to getting 5, we need something in right. So 0 is not a possible case. So it starts from 1. So 1, if I get in first roll, then in another roll I'll require 4, right? So 1 4 2 3 3 to 4 1. These 4 possibilities are there. It's count as 2. So there's saying 5 ways of getting sum of number as 5. So that's not correct. The experiment is not random experiment. It's a random experiment. So subspace of this is start from 1 comma 1. Let's say 1 comma 2, and it goes like this, right? So this is 6 comma 1 and 6 comma 6, right? So all like 36 possibilities are there in a sample space, and it's a random experiment. Anything can come out. These all are outcomes of our so the experiment is not random, so that's why it's incorrect. Getting the sum of 12 is an event, which is true. Getting sum of, if you get 6 6 in both, then only you can get 12, right? So it's a event, smaller subset of sample, right? So let's say this is E, and say smaller subset of S, right? So that's why it's an event, and it's come out of some sample space. So only statement 3 is correct. These 2 both
Sir,
are wrong.
can you please explain the option 2, sir? The experiment is not a random, this one.
It's a random experiment, right? Since
Hello, sir.
yes.
Sir, what is difference in random experiment and experiment?
So any thing can become experiment. Any any process, right? Any process can
Okay.
become experiment.
Process are there outcome.
Yeah. So outcomes. Let's say if you have predictable outcomes, right? The outcomes is defined, right? So that is like controlled experiments, right? So this is what called controlled experiment. And outcomes are defined. Let's say you mix colors. Let's say like red plus green or something, and you get some color which is already maybe yellow or something, right? I don't know, but this is like defined or controlled experiment, right? Or let's say you mix red color in water, then you'll get red color water. I mean, you know it, right? There's no randomness in it. There's no another outcome you are expecting, or you're gonna get, right?
Yes.
So this is a controlled experiment. It's not a random experiment. In random experiment, anything can come out. Okay, so outcome is not defined. Like outcome
Not
is predictable. Outcome is not
predictable.
predictable, right? So, but you will get some outcome after you do the experiment. So after experiment is complete, you will get some outcome. Okay, not before. So it's not. It's the unpredictable part makes it random experiment.
So,
Okay.
Yeah.
So, for example, just consider if something has the probability of 99.9% to happen, right?
Okay.
And other has 0.1%.
Okay.
And we just do this experiment.
Yes.
Will we still call it a random experiment or something? Because 99.9% probability is already fixed that it will happen. But
Yes.
0.1% is still not
Yes.
clear, not sure.
So okay, so how I mean, yes, it is a random experiment, but there is condition of random experiment is you should know all the outcomes. Okay, all the outcomes are known to you. So possible outcomes, all the possible outcomes should be known to you. That's a requirement to
Should be
solve the
known,
problem.
or you can derive the possible outcome.
Derive is also there, but
I mean,
deriving would
there could
be
be number of ways in which you can put the events, right? and you may not have ready answers. I mean, you can calculate it, but you may not have a ready answers, right? So I think
Yeah, so but at least you know, right, what is possible outcomes. I mean, it can't go out of sample space. So sample space is important. If you know the sample space, basically sample space should be
Sample
known.
space is a collection of all possible outcomes.
Yes, all the possible outcomes. Yes. So that is sample space, right? So if you know this, then it's a random experiment.
Okay.
Okay, so let's say if you don't know the possible outcomes, if something is gonna happen. Let's say you there is an experiment going on and something came out, which is also unpredictable, but you don't know. It never happened before, or you don't even know what's gonna come out. Then it's not a random experiment. Like we don't we don't say that this is a random experiment. Then it is like a uncontrolled experiment or something, something like that. We don't do probability there, since we don't know what is it, right? So we can only the 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 point is we wanted to find probability of something happening. This we can only do if we know the outcomes, possible outcomes. Okay. Yeah. Okay. So why? Okay. So second point, somebody asked that the experiment is not a random. It why it is incorrect? Because we are rolling a die, right? Rolling a die is a random experiment. Like that's the basic of explanation of random experiment. That if you roll a die, you get outcome 1, 2, 3, 4, 5, and 6. Right?
Yes, sir.
If you roll 2 dice, then same thing, right? Like you'll get another this numbers. Now you are summing up. Now you'll do sum or something, right? So let's say 1 comma 1, 1 comma 2 or something. You will sum this. You get 1 in one die and 2 in another die. So that's how it is. So that's why it is also a random experiment. And all the outcomes are known. All the outcomes are known. Yeah.
Yes, sir. Understood.
Okay. Uh, see. Okay. Few people selected 3 to 4. Wait, that this is okay, that's fine. We can move on. So next is the so this is the explanation I already did, and yeah, 2 unbiased dice are thrown. Find the probability that both the dice show the same number. Okay. I'll give 3 minutes.
One by 6.
Hello, sir.
Yeah, hello.
Well, what is the unbiased die?
dice is a
I know
dice.
dice, but
Okay.
unbiased die.
Unbiased means it's fair dice. Something. Let's say you are not
Normal
tempered.
dice. 1,
You're
2,
not
3, 4, 5, 6.
tempered it.
Oh,
Yeah,
okay,
yeah.
okay.
Normal dice. Or you are not getting one number more than another's. Let's say somehow you tempered the dice. It's not like that. It's a fair die.
Okay.
Not manipulated. Yeah.
0.16.
Okay, 38. 9. Okay. How many? Okay, 166. How can probability be more than?
Sir, I am taking this test in my Android phone, and there is no point, sir. 1 to 9 number only showing, sir, in calculator.
In calculator?
I mean, sir, my answer is 0.166, but I can't point decimals.
So how? Okay, I don't know. Let me try. Okay, let me try. I think you can. So let's say it says center number here 0.16. I'm also able to do it, right, in my mobile, which is Android.
Yes, sir. I am also.
You get like if you use that a slider or whatever side inside you have, then you can't. But you have to type it.
It can be his device problem, sir, maybe.
Okay. Yeah, but that's okay. You got the answer, right? So in like if you know the answer, that's more than enough. Okay. Yeah. So see. So I mean, do you need explanation? Right? This is one of the easiest
No,
questions.
sir. No explanation.
No, sir.
Okay.
No, sir.
Okay. Let's move on then. Okay. Yeah. So it
Sir, I
says
have shared photo.
0.17, but we rounded it off. Okay. So it's if you do 0.166 and still your answer is correct. It would be in range only.
Sir, I have shared photo, sir.
Photo
in chat.
In chat, okay. How to respond to
sir.
question? Yes.
Sir, I have a doubt.
Yeah, go ahead. So what is the doubt?
Sir, both dice that show the same number. So why is a 6/36?
Why 6/36? Okay. Do you?
One die is a 1/36.
No. What are you doing? Like you have to write all the sample space, all the outcome in a sample space, right? So let's say see here it is total number of possibilities, that number of outcome in sample space is 36, right?
Okay, huh?
You can get 1 1 1 2 1 3 1 4.
Sir,
Then
it's a one die, but it's a option is a two die. Dice.
Yes. So in both of them, same outcome required, right? That's what the
yes.
See, two unbiased dice are thrown. Find the probability that both the dice show the same number. So they both have to show the same number at the same time, right?
Yes.
So how will that happen? So if 1 1 appears let's say one appears in first one and one appears in second one, then two appears in and so on, right?
Yes, yes.
Then only possible. So there are 6 ways. This is the count is 6, and total. So you have to find the probability of this happening. So out of all the all the possibilities, count of sample space, so which is 36.
Yes, yes.
Okay.
Sir, if each 1, 2, 3, 4 till 6, each of them have 1/6 probability. So when there are two dices, shouldn't it be like 1/6 into 1/6?
So you are saying why we are not taking 1/6?
Yeah, because for getting same number, both will have 1/6
Yes.
probability.
Okay. No, this is for one outcome, right? This one you are saying. Then you have to
Yes.
sum it up. Okay. So
But how the question should be for one outcome, right?
no, but you have to take all the possible outcomes, right? In the while finding the problem. So they're saying both the dice should show the same number. So this is one event. So
Way.
if you write the event, let me write the event. Okay. So if you write the event, and let's say I'm writing all the possible outcomes of event, right? So that is 1, 1, 2, 2, 3, 3. So you have to find for all of them, right? So this happen or this happen or this happen or same thing, right? So let's say first one will happen when 1/6 multiplied by 1/6, right? Then second one will happen. How many ways to get 2 out of 6? 1/6, right? Then you multiply that, but you need to add that because
Add them.
or is there, right? So if you do that is like 6 times you are doing it, right? So total like 6 times 1/6, 1/6 into 1/6. Yeah. So that's how you get this 1/6 answer, which is also equal to 6/36, right? And 0.16 or 17, whatever. Okay.
No, that would be 1/6. Like if you multiply it by 6, so it would be 1/6. Yeah, same thing.
Yeah, that's what I'm saying. That same as 6/36, right? And I mean, you have to add them. You maybe didn't do it, so.
Can I explain another way of looking at it so that easy to understand?
Okay.
There are 2 times we are going to throw the dice. First die, we have no expectation. It can come anything. It doesn't matter. So there is no probability for that. We are accepting the full sample space as the event. Having that happened, we have now a fixed number, which is the first outcome of the first die. So the second die has to be the probability of matching that, which is 1/6.
Yeah, okay.
Okay, if you look at this way, it's one way of understanding. Otherwise, as you explained, if we are looking at both the dice to be the same number, then we are going to look at the actual event is as you listed down 1, 1, 1, 1, 2, 2, 3, 3. Whereas the possibility is 6/6, 36. That is why it is 6/36. Again, it is 1/1/6.
Okay.
Is that clearer? Yeah. What is that?
Yes.
Okay.
Is this students who have joined now, how to respond? You have to join this PD joinpd.com, right?
What is that?
Joinpd.com is a website.
Okay, for the screenshot. Okay.
For this, right? So this is a peer deck. This going on. So you have to give the response here. You'll get this. So this is like joinpd.com. And then so if I okay.
Thank you.
Sir, I want to ask about one doubt about extra activity.
Yeah.
Sir, how to join? Oh, so.
Sir, can I speak now?
Yeah.
Sir, I am asking, sir, what type of data can we choose for our extra activity, sir?
Any kind of data, right?
So there was some limitations. So I was.
Yeah, so it should have like 5 columns and 1,000 rows. That's all. Like, so basically we are saying that
Can we take government data or we have
yes,
to take?
any data will work, but you have to cite that data. So you can take it. Yes,
Okay.
Excuse me, sir.
yes, yes.
So what is the code for
This one,
joinpd.com?
this one, HEIFOU, on the screen, present on
Okay,
the screen.
thanks.
It will be at the right top, right? So have you ever done this solve with us session?
Yes, sir. Okay.
So then I'm like, we are in week 7, right? And still
Yes, I've done it so
you,
many times.
yeah, right. So I'm like, still we have to explain. That's not good. Okay, let's move. Okay, so this 0.17. Okay, so now okay, same experiment. And the question is the first ratio 6. Mm, probability of that. I'll give. Oops.
What's the code? Join PD is asking for a code.
The code is,
HIEFOU.
this is the code.
HIEFOU, right?
Yes, yes.
Okay, thank you.
HIE.
Well, side name
Joinpd.com.
joinpd.com.
Yeah, it's in chat also.
Code is also written in the chat.
It's always same, right? Same website. We always use the name.
Yes, sir.
The link is always same.
It's asking what I'm filling.
Can we ask a question also right now? I mean, even though we can solve this, but just for a fundamental clarity.
Yeah, go
when
ahead.
we say
So,
the first, yeah, when we say the first die shows 6, these two unbiased dice thrown simultaneously, right?
yes.
So it is not the first one which is thrown, right? It is what is the occurrence of we are finding that 6 will come at least on one of the dice, right? That is called first die shows 6. Correct?
I
I mean, out of
think
the two
that.
dice, when we get the first 6, correct?
Yeah, I think
Is that the question? Yeah, okay. No, because there is no first or second dice, right? I mean, both are thrown simultaneously at once. This is, I just want to just wanted clarity on
Okay.
this.
Yeah, go ahead. We will take that
0.17.
assumption. We'll take that assumption and go ahead. So maybe.
Okay.
It has got a point because you're saying first die, there could be a question saying one of the die shows 6, then the choices are different.
Yes, definitely.
So I think questions need to be a little more specific.
Precise. Yeah, okay. For now, just assume that one shows.
Definitely, the way it has been put up, there is a ambiguity.
Correct.
So the answer is going to be the same for all the values, right? 1, 2, 3, 4, 5, 6. 0.17.
0.17. Okay.
So because the probability of each number is the same, right?
Yes.
Why are we saying two dice? We are talking about only one die, then we'll talk about one die.
I'm also talking about the single die only. No, I'm saying 1, 2, 3, 4, 5, 6 are the outcomes of each die of a single die.
No,
they will be occur in pairs, right? They will occur in pair.
Okay.
It says your responses are locked.
Yes.
Can we give the answer? I don't know.
We got array of this. Okay. So there is a little bit ambiguity, but we'll see what is the solution. So okay, they are saying okay, only one has 6 and not the second one.
Oh, then the question was completely different then. I thought anywhere you get 6 first, right? Out of 36, which comes to 2 by 36, which 1 by 18 is the probability.
No, 2 by 36 is still, let's say first.
No, because
So
you'll get, there are possibility, like total outcome is 36, right? And both the dice have number 6. Right. So possibility of getting 1 6 out of 36 is 1 by 36 plus 1 by 36.
no. Let's say first one got 6 and then rest anything got, right? So that is 6 by 36. But let's say even if you thought that another could be first also, so like there is no order now,
Correct.
then you have to consider that also. Then you'll get 12 by 36.
Look at it this way. Instead of 2 dice, even if they throw 10 dice, each die will have a chance of 1 by 6 to show one of the number.
So yeah, okay, this is little ambiguous, but it's true that we need to show that what is one, first or second. There is no first or second, so we can maybe say that only.
Basically, the die shows up one of the numbers or 1/6 of the time.
Yeah. Okay. Okay. So let's move on. The same question, same experiment. I'll give 3 minutes for this. So the total number of dice is greater than.
Response here is it? The total numbers on the dice.
That is sum of the total number, right? It cannot be.
Yeah, sum.
Okay.
Total. So they are saying doing total of the numbers, but that is sum of the numbers of the dice.
Greater than 6.
Greater than 8.
So what is the answer for previous question, sir?
0.17.
0.42 is the answer.
Okay. So submit it. Okay. No need to speak to everyone. Basically.
Sir, in previous question, if we write 1 by 6, that is also correct.
6 by 36, 1 by 6, everything same, right?
Oh yes, so sorry, sir.
Someone tell me, how do I give a response?
Of what?
Whatever is that, join or whatever.
Joinpd.com.
Join video. I put the number, but it doesn't go. I mean, that's it. I just enter the number and that stays there. There is no enter key or something, button submit.
It has been submitted.
Sorry?
It has been submitted. You don't need to press enter or anything.
Okay. Just whatever keyed in, it gets.
It will automatically submit.
Yeah. Just you type
the answer,
it.
it gets logged.
Yeah.
Okay. So I think this is also very easy. So we can get so 36 outcomes are there, right? So out of that, they are saying that how many ways to get greater than 8. So maximum, okay, so minimum possible sum is 2, right? They both got 1. 3, then maybe you can go, and the maximum is 12. So they are saying that when you get a greater than it, so 9, 10, 11, and 12, how many ways this can happen? So maybe you can write that only okay, sorry, only one possibility here, that 12 is the sum, both are 6. Then let's say in 11, one got 6 and another got 5, or let's say 5 and 6, right? So this is a possibility. 10, you can write let's say
5, 5.
6,
6,
4,
5, 5.
then 5,
4,
5,
6.
Sorry,
and
sir. 3, 6 not possible. 3, 6, 4, 5,
3,
4,
9,
6.
9.
Yes, correct. 6, 4, 6, 5, 6, 6.
no, this is
Yes.
for 10, right? 10, getting some 10.
Okay,
This
for
is
18.
some,
Oh, okay.
this is
Okay,
getting some
alright.
11. This is
Yeah.
getting some 12. So for 9, we'll write 6, 3, then 5,
3,
4,
6.
5, 4.
then 4, 5,
3, 6.
3,
3,
6.
6.
then 3, 6, right? So this
6, 6.
all possible abilities are there. That's all. Okay, so you can count them. Let's say 4 plus 3, 7, plus
10.
2, 9, and
It's
10,
10,
right?
sir.
So 10 by total are 36. So this is whatever the numbers are there. So you can,
But
0.27.
here, 3, 6, and 6, 3. Do you want to consider this as a two separate event?
yes, because
Two
in
separate
Yes.
outcome?
die 1, 6 appeared, and in die 2, 3
But
appeared.
when we throw the dice and mix the dice single hand, how do you know it's 1 or 2, right? I mean, we are getting the same outcome. We cannot identify one time, okay, which is the first die, unless and until it is different color, right?
Yeah,
But when you throw
but
the
still
two
we have
same
2 dice.
dice,
Yes. But that is like you can't figure it out. It's a visually, but that doesn't mean it's not different one, right? Uh, it's not about visual scene, like total
no,
sample
I
space you
understand.
have
I
to
was
see.
just checking
Yeah,
mathematically whether shall we consider 3, 6, and 3, 6, and 6, 3 are same, and then we should count it as only once, or
no,
we
no,
should count it double. That's
double. Yeah, that's a different case.
Sir,
Yes.
there's a other rules. Is a 3, 6, 4, 5, 4, 6. It's not possible.
It's here, right?
Huh?
It's here, this on the screen. For 9, right? Getting some 9. This 4 possibilities I wrote.
Yes. But yes.
I mean, all the possibilities are written here.
Okay. Yes, okay.
Just have to sum it up. So now count of this, right? So 4, 3 plus 2 plus 1, which is 10 by 36 is a total outcomes. So whatever this number is, it's the answer. Okay. And
sorry to ask you again the same, but just to get a fundamental clarity, right? In some of the examples, we talked about not repeating this alternate, right? 5, 4, 4, 5, 3, 6. So where is the fundamental thing that we should consider when to choose separately and when not to consider? In the set, the order is not important sometimes, right? Then
yes,
is it important to include 3, 5, 5, 3 or 3, 6, 6, 3, 5, 4, 4, 5? Is there any basic rule that when to consider and when not to consider?
no, there is no rule.
Actually,
It
in
depends on
relation, it's
question.
important. Actually, in relation, it's important. The order, like 4, 6, and 6, 4 is very important. You have to, these both are different things. Like 5, 6, and 6, 5 are different things in a relation, which is made through a set.
Yeah, basically in this is a experiment in which we are taking 2 dice, and both are separate in itself, right? So we can't say this both are same thing or something. So here
Okay.
we'll take different things.
Okay,
Let's say tossing a coin. Even though we toss the same coin twice, still it matters, right? The first one you got head, and second one you can get anything again, head or tail. So that's why this we take them as a separate or different outcomes.
Okay, not a problem.
Okay, so this 0.28 is the answer. Okay. Okay, next question. So this is on, it's a set.
It's a very easy.
Yeah. can okay, try it. So there's an addition rule. If you are facing difficulty, this is addition rule.
Sir,
Yes.
sir, the portion for August for exam week
Sorry?
1 to 8 का. The portion for August for exam is something.
I'm not getting you.
Week 5 to
Sir,
week 8.
Oh, okay.
so
Week
the
5.
portion for
Portion.
August for exam. Foundation level exam.
Okay, quiz 2. Okay, quiz 2 exam syllabus is week 5 to week 8.
Only
Week-
week 5 to week 8 on week 1 to week 8.
Week 5 to week 8.
Okay, okay. Thank you.
In
The
all
week
the subjects
5
or in only statistics?
In statistics only. I'll only
Okay, sir.
yeah.
Sir, one general doubt.
Yes.
My submit is week 6, week 5, and week 6 graded assignment, but my current course is not add.
Current course is not added
My score is not added.
for week 5 and week 6.
You go
yes.
to score graded, there you can see your score, because in my dashboard also it is not able to see that. Yeah.
Grade is okay. Okay.
No,
Everyone
they
is
will
same problem.
automatically update. Don't worry about that. They will update.
Oh, okay, okay.
Okay. Okay. Very
Sir,
low
will we
response.
discuss permutation and combination questions also after probability ones?
Yeah, there will be few on that also in this. So yes, okay. So 0.1, then 1. Okay. Okay, 1 is the 0 is also there. Okay, so that means never happen. This thing can never happen. And they are saying this thing always happens. Okay. I'll solve. So this very easy in terms of if you see, A and B as a one unit or something like that's a you so you have done P of, let's say, C and D happening, right? Something like that. That's it. Of course, A and B is there for you, but let me take C and D just so. P of C, then you sum P of D, then subtract out whatever is common between them, right? So common between C and D is like intersection of C and D. You take common out of that. So that's what they are saying. They also given kind of that only. So they are saying let's say this is the D or something, right? So that's what they are asking, C intersection D. I can swap it. That's okay. And they are asking what is the question is what is the probability of happening A or B and C, right? So it's like P A or B. So basically A can happen.
Treat A or B as even D. It will be easier for us. You've taken the right step. A or B, A union B is equal to D. Then it will be
yeah, that's what. So it's like written opposite way will work. No, should I write that way? Okay, let me write. So you can take this as a one entity, okay, because you're given that. That's why. Otherwise, I would have taken B and C as a one unit. Okay, if I was given that, because I know C, I know this too. Okay, so since I know whatever I was known, from that I am making this. Why I am taking this as D and not that, because that's what given to me. Okay. Yes. So they are asking. When you see this thing, you should think like what they are asking. They are asking that, see, A can happen or B can happen. Okay, and C has to happen, right? So either A and A and C happens. A and C happens, or B and C happens, right? So these two are like this. So this is understanding of that. But even though if you don't want to go into that, then you can directly just solve using set and all, right? So let me try to draw Venn diagram if I can. Yes. Yes.
So can't we make an equation with that? Like we need to find P A union B intersection C, the probability of that. So can't we make an equation by taking all the union, like probability of A union B union C minus probability of A union B's complement? Like this will give the same result, and we know what is A union B, which is 0.5. So we can just subtract 1 from that, which is 0.5. So we got the value of the complement, and we have to find A. We just know the value of 0.6. No.
Yes.
So like A union.
There are several ways you can solve it. You can take complement, then do it, or you can subtract it. So yes, there are many ways, right? So what they've given is they have given this part, right? So this is A. No, they have given A or B or C to happen. This or this. This is A intersection. That's not given. Let's see if I can do it for Venn diagram. I never tried this. So I can do numbers and do it, but let's see if it's possible. So I have this all things I have. They've given, let's say this is A. This is
it's going to
B.
be tough because A and B, nothing much has been given.
Yeah. So
you can't put a Venn diagram.
Yeah. Let me try. I don't know.
Okay.
We can try. Okay. A or B. Okay. A or B. So I think A is the complete A or complete B.
That's correct.
That is 0.5. Okay.
Shade it.
They are saying the whole thing. The whole thing, like A or B or C. Yes, that is 0.6. And now they're asking what is either A or B happen. And along with C happens. Okay, so this is a little complicated.
You can, I think you're right. All three shade together is 0.6.
Yes.
So
no, not shared, just shared. All the things.
All of them together the same. So if you remove the disk of C,
So
you get A or B, which is 0.5.
So this portion is 0.1.
That's correct.
Right. Yeah. So
That's correct.
yes, and they are asking what is A or B. So this much portion is given to us, that is 0.5, right? This portion, this is 0.5. They're asking and so common between that and C. So that they are asking about.
It should be 0.1 because C is
No.
0.2.
They are asking about this portion, right? This.
No. Total C is 0.2. Exclusive C is 0.1, which you just now found.
Yes.
So the common with the A and A or B is 0.1.
0.1.
0.1, yes.
Sir, 0.1.
One diagram works. You're right.
The point on chance.
Yes, it shouldn't be 0.1.
Yeah.
Sir, in addition rule, we have talked.
So I'm saying this is the whole thing.
So the whole thing is 0.6, right?
Yes. So the whole thing is 0.6.
Right. And A or B is
that is 0.5.
0.5. So
And
obviously
this is,
C without A and B is 0.1. That's what you wrote.
No, Venn diagram doesn't work, guys.
No, it works. It works.
It works.
It did.
Because we don't have a data, sufficient data here.
Yes,
I
that's what I also thought, but no, it works. He's right.
No.
Wait. So I think 0.1 is not the correct answer. That's
answer is right.
No, that is the answer if we solve this by addition theorem also.
But then you can't solve with this one Venn diagram. Only
Right.
formula.
Sir, in addition
Yes,
theorem.
sir. We have to do with formula, sir.
Yeah,
In
okay,
addition
okay.
theorem, sir.
Yeah, okay. That is
Yes.
okay. It is 0.1, but okay. I think I was doubting myself, but yeah. So see, same thing. You can do it with Venn diagram, but what I did is correct. But let's go with formula. Okay. You can whoever got the idea with Venn diagram, they can try that. Otherwise, okay, formula is always there. That's why we have this when imagination doesn't work or something like Venn diagram is not, you are not good with that. So what they are saying is they made A or B as a D, right? So then you can write this what till this we were able to see, right? This is what till this much I wrote it, that when you have two D and C what you call D and C events, then how will you write the addition rule? So you say that I'll sum probability of C, probability of D, and then whatever common between C and D, I'll take out that, right? And that's what they are doing. So this what all the things are given, right? P of C was given, P of D is also given. So P of D is this P of D. Okay, this is P of D. Since I'm calling this as D, this is D, right? So I know all the things. I see P of D union C is P of D, which is this one. Then they are asking P of, so then I have to sum P of C, which is this one. And then they're saying subtract whatever P of D and intersection with C. So intersection is here. So this is what it is, right? So this is what actually I need to find out this. This is my question. Okay, so I'll just send it here and maybe bring this guy here. I can swap it, right? Around the equal to sign. It's just mathematics, and then you can find this thing. So I know this one, P of D, this is 0.6. So what I'm doing is I'll write P of D as 0.5 plus P of C, which is 0.2, and I'll subtract this 0.6 from that, which is 0.1. So yes, you can do with this also. Okay. Yeah. I think clear, but you can see this if it's not clear. It's written here. So I'm taking this section and I'm just so we always write this way, right? A D or C happening, then we do this. So we can swap this part, intersection part and union part, same thing, and then you can find the answer. Yeah, it was very easy. Just I drew the Venn diagram. If you didn't get that, you can try drawing that. I think it's same answer. Okay. Yeah. Next question.
Hello, sir.
Hello.
Sir, this what is the value of complement? But it's not a complement.
Which is not a complement.
It's P A union B union C.
Yes.
It's a complement. It's not a complement.
No, it's a event, right? This is the
Event.
Yeah, so you have to find the complement of that, right? What is the probability of complement of this?
It's 0.4.
It is given, right? Say this is given. Then they are asking about this, so which is like what?
Oh yes, yes, I understood.
P plus P of C is 1, right?
Okay, okay.
You can go for the answer.
Yeah.
At 0.4.
It's very simple.
Okay, it was simple, right? The one thing is this is given. They are asking complement this, which is 1 minus 0.6. So this is 0.4. Okay.
Yes.
Okay.
Hello, sir.
Yes. Hello.
Sir, 5 weeks already passed ago, but still the course drop window is not showing on dashboard.
Which course window?
Course drop window for dropping course.
Okay, I'm not sure about that. How does that happen? You can maybe mail to support.
I have mailed, but the reply didn't came. Then after one.
Okay, now, okay, so there's a variation in. Okay, then actually I don't know how this dropping happens. Okay, okay, I'll give let's give 3 minutes. It's a new question, and one is of each color. Okay, now your skills of permutation combination will be required.
Yes, sir. It's easy.
Sir, EMQ questions will also come in our exam in quiz 2.
No, there will be no aim.
Okay.
Zero point 0.22.
Sir, answer is a 11.36.
0.22, I think.
0.22.
Okay, we will solve.
0.2.
Why is low submission? Is it hard?
No,
Think
sir.
it's
No,
easy,
sir.
right?
No,
Sir,
sir.
it's a 6 complement 1 into 4 complement 1 into 9 complement 1 divided by 19 complement by 3.
Combination.
Combine.
Oh, combination.
Choose.
Yes, combination. Choose.
Yeah.
Okay.
Yes.
Okay.
Okay. Okay. So, whenever you get this type of question, first thing you should always think, what is my sample space, right? That first you should always think of what is my sample space. So the sample space is choosing 3 balls, right? So all the outcomes of choosing or selecting 3 balls, right? Drawing the 3 balls. Yeah. So let's say first came out white, second also white, third also white. So then first white, second white, and maybe let's say this numbering is 1 2 3. Then maybe 1 2 4 can come out, and likewise. So all the things are there, but this will be all of them will be out of the sum of this. So there are 6 white, 4 red, and 9 black. So if you sum them, that is 19. Out of 19, choosing 3
C3.
is the total count of the sample space. I can't write it, but this is a huge number. So this is a sample space, right? Which is if you do a probability, then you create all the count here, and then this is my event count, right? So count of that event. Then that's how you are gonna find the probability. So this was done 19C3. Now I need to find this M part. What is that? Okay, so they're saying find the probability. This is my event. That one is of each color. One is of each color is my event, right? One of each color. Let me write one of each color.
61419 216 हो जाएगी 6 into 4 into 9.
Yeah, so out of 6, okay, I need 3. I have 3, right? So choosing first, so I need to choose one of each color. Hello. Yeah. So out of let's say this is white, this is red, and this is black. Okay. So choosing a white ball out of all
6C1.
6C1, right? And this is red is 4C1, and this is going to be 9C1.
9C1.
Right? So this is like 6 into 4 into 9, and then you have to divide that by 19C3, right?
19C3.
Right. So this is the probability of this is the answer of this. You can solve this, and this is the answer. Okay. Anybody interested to see how to solve this without permutation?
Yes, sir. Sure.
Yes, sir.
Yes, sir, please.
Okay. Okay, so let's say I have not say, but I have total 19, right? So let's say I choose one ball, first ball of any color. Let's say red. Let me choose white. Okay, so let's say first was white. What is the probability of choosing a white ball? First white ball.
1 by 6.
By 6.
No, out of 19.
1
6
by
19.
6 by 19.
6 by 19.
Right. So yeah. Okay. So out of 19, choosing a white ball is 6 by 19, right? Then let's say choose second ball. That's what the combination is required. W, R, and B, or any other combinations of this. So that is 6 by 19. Then I have 18 remain in my that urn. Out of that, I need to choose red, right? So red is 4 by 18. All the 4 are there, not any one of replaced, right? Then I have 17. And how many are there left? How many black balls are there? 9, right? So this is one way. what others could what other way happens is, like, let's say first I choose red, then choose blue, then choose this, right? This is also possible. That if I go this way, then choosing red is 4 by 19, then 18 left. Let's say I choose white, which is out of 6. Then I have 17. I choose out of 9, right? So this you can write all the 6
Sir,
combinations.
plus. It should be plus, right?
Yeah, like it's just plus, but yeah, this all will add. But how many such variation will be there of 3 balls?
6.
6 ways, right? Like RWB, let's say RWB, RBW, B, RBW, then it's a blue. If I take, then RP and WBR, then if I do what left, B. If B is there, then WR and BRW, right? So the 6 possibilities are there. You can find like 3, how many ways to arrange them, right? 3 factorial, 6. If you don't want to write all the cases, let's say sometime it becomes hectic, then 6 factorial, right? So this, for all the cases you can find, you'll get always this part only. 6 by 19 into 4 by 18 and 9 by 17. This anyhow you will get this only, right? It just order will swap. So I need to sum all this 6 ways of happening this. So 6 times 6 by 19, or 6 into 4 into 9. Let me write that way. That is much better. Let's say, okay, 6. Okay, 6 multiplied by 6 into 4 into 9 and 19 into 18 into 17. Okay, this is still same. And if you can see, this is what 19 C3. Like this 6 came from this. So if you do that, this like 19 factorial divided by 16 factorial into 3 factorial, right? So this 3 can go up here if it's in a division. And 16, if you do the 16 factorial and 19 factorial, then you'll get 19 into 18 into 17, correct? So it's the same thing, like whatever you did. We did like 6C1 into 4C1 into 9C1, and we did 19C3. Okay. It's just the elaborate way, but this is only possible because I have the same this outcomes and all, but knowing the combination part is still always helpful. Okay, you can easily solve this way. It's just a long way. Okay, we can move. So the next answer is this only, 0.22. Okay, whoever got 0.2 is correct. Next question. I'll give that none is red color. Okay, I think I can give 3 for this. Hello.
Sir, in which place we got the answer for?
Sorry?
In which place we going to answer the question?
Have you joined the solve with us before?
No, sir.
Ever? Okay, so you have to go to this website, joinpd.com. This is the website. You give this code. This is the code you write there, and you can continue it, right? So you'll get the question which is appearing on the screen here. So basically there you will just get the option or something, numbers or like.
Okay, sir. Thank
you. Hello, sir.
Yes.
This is a 15C3 divided by
Yeah,
19C3.
whatever. Submit the answer. That's
Okay,
okay.
okay.
Sir, we will get to mock 2 quiz also for
Yes,
practice.
Yes, you'll get mock for quiz too.
So no need to prepare a week 1 to week 4 for a quiz 2, right?
Yes.
One day you
Only
can
week
prepare.
5 to 8. Yes.
Okay.
Only 4 weeks.
Because somebody say it has weightages. So if you
No, there is no weightage now. In quiz 2, no, not there.
Thank you for the confirmation.
Only week 5 to week 8.
Yes.
Okay. And sir, September
September
is a term 2.
Term
Hello?
2. Yes.
September term 2 is a week 1 to week 12 or week 8 to week 12. Next.
What is September? I mean,
The
how
end term
He's
is
saying
that.
about
So
September
September
term.
term, not 2.
Oh, end term.
End term. Yes, end term.
Okay. In end term, you will have all the weeks, week 1 to 12.
Oh, okay.
So again, what might be the weightages for end term?
So you'll have higher weightage for week 9 to 12. Then you'll have little bit weightage of all week 1 to 8. So
Yes, understood.
yeah, less, but week 9 to 12 will have higher weightage.
Okay, thank you.
Sir, excuse me, sir.
I think it's done, right? So okay, 25. Do you need more time or?
No.
No,
No,
I'm
sir.
not able to write that, so can we get some time?
Sorry?
I'm not able to type an answer, so can I get some time?
Not able to type that's why is that?
So can you please give me 30 seconds so that I can type the answer? I'm not able to type an answer.
Okay, let's say 30 seconds. Okay, I'll give 30 seconds to ask.
Yes.
Somebody has anything else? Somebody was asking something.
Sir, it was me, sir.
Yeah, what was it?
Sir, for me in the dashboard, it still says that I'm in the qualifier. Sir.
But you are now you're qualified.
Yes, sir, but I have already qualified.
That's okay, right? I mean, you still get same portal. I mean, the portal, I mean, even though you come here, you get same thing, everything, quizzes and like not quiz, like activity question, grade assignment. So there's nothing different there. But I'm not sure if you are supposed to move to some. So I know there is another portal. But are you supposed to move there or just you need to continue there? I'm not sure about that. But it's same. Like there is nothing different between them.
Okay, sir. I'll mail
Sir.
the support.
Okay. Yes.
Sir.
Yes.
Sir, I have a question that if student gets qualified and he will enter in foundation level, he will be also giving the exam of week 5 to week 8.
Yes, who are qualified, yes. Okay. Let's solve this. It's like one of the very easy questions. So find the probability that none is the red color, right? So how many reds are there? 4, right?
4.
Yes, 4 are red, and
yes, sir.
So that leaves like how many? I need to do. I have options like 6 plus 9, 15 options are there, right? Then they are saying, okay, none is red, right? So let's say I choose first one out of 19. So which should come out of the 15? Basically not red. Then I multiply that with 14 by 18. then I multiply that 13 by 17. So this is the answer. If I do with permutation combination, then total ways of choosing 3 is 19C3. And then they are saying I have 15, right? So out of 15, I choose 15C3.
15 by 3.
15C3, right? So this is
So
permutation.
can we do the conjugate thing? If we first find the
yes
total probability for getting all red, and then we do 1 minus that probability.
Yes, you can do that. So that would be, if I do that way, then let's say choosing first is red, that would be 14 by 19. Then second also red, so that is 13 by 3 by 18, sorry. And then 2 by 17. So this is finding red, all the 3 red. None is of red color. And all 3 got red, so I subtract 1 out of that, then same thing. I think same. So this is also possible.
Sir, in first method,
yes,
sir, there is no arrangement like 2 factorial or 3 factorial.
no, because okay, see, we are not taking red at all, right? There is no actually arrangement. We have two types of you can say we have two types of balls now. One is red and one is not red. Okay, not red. These two types are there, and I'm not choosing this. I have this
Okay.
only. So there is no point of arranging same thing.
Yes, sir.
Okay. Yeah. Okay. So let's move. 15C3 by 19C3 and answer 0.47. Okay. Now
we talked about removing all reds, right?
Yes.
Probability of getting all 3 red is 4C3 divided by 19C3.
But yes, you have to subtract from 1, right?
Correct, but that's a very, the answers doesn't seems to be matching. Something is.
Okay,
there is one red.
Oh, it's logically, I don't know. I mean, when I do the number, they don't match. So there must be something which we are missing in this.
This is because there is another case like one red and 2 others, and 2 red plus 1 others.
Correct. The logic of finding the probability that at least one ball is not, I mean, none of them are red. That's what the earlier question was, right?
Okay, you try this. I'll look into that. Okay, I'll think about that.
That's okay. We changed.
So what I'm saying is What's happening, guys? Not able to solve these questions, or are you facing difficulties anywhere?
Solve, sir. It's
No,
easy.
no, sir, no,
It's
sir.
a
We
one
need
question.
more time.
No. Okay. So for you, it's easy. That's okay. But see, there are 78, let's say, participants currently in the meet, and this is at least. I mean, I'm expecting at least 40, half of the people should submit. So this is very easy questions, right? This will lay a foundation for you to solve all the probability questions. Later on, conditional probability will come up. Then, random variables. So those are like the upcoming topics in next weeks. And if you can't able to solve this question, then you'll face very very difficult to solve that. But then that time will not. We can't again and again explain you all the concepts, right? So since it's starting from permutation week 5.
So could you give 30 seconds? Like I was not able to type it.
Yeah, okay. So do you need more time? Okay, how many were able to can solve this in 1 minute? If I give you 1 minute.
Yeah, 1.5 minutes.
Okay, I'll give 1 minute. Okay. Solve this.
No, done. I thought you were asking how much.
No, we are done, sir.
Very done.
Okay. For others, I give 1 minute. Okay. Solve this. Try at least try to solve something. Give some answer, wrong answer. Then you'll know that what you did wrong. What is the logic is wrong or something. Approach.
Excuse me, sir.
Yes.
Sir, I'm new. I'm not understanding anything.
So new means how new?
I just came to know today that the class is going live.
What you have done till week 7 you have studied, right?
No,
Then till which week you have studied?
I have joined today for the first time.
And before that, I mean,
No,
and what about the previous classes or previous weeks lessons or?
No, I have not done anything. I am in the right batch, right?
Then I'm not sure. Maybe you're not. Have you? So have you like completed qualifier? Have you passed that?
No, I
Are
have
you
registered for it recently. Like 1 week ago, I have just registered it.
for qualifier exam?
Yeah, I have.
No. Then you
September
are
batch.
okay. Then you are not in right class. We are at week
Oh,
7, so you are supposed to learn week 1 to week 4.
oh, so how am I supposed to know when it will be like
Your
a
class is
classes?
not a start.
Yeah, I think you. So have you given previously any exam? No.
No, sir.
This will your first. Okay. Then your class will start from I think September or something, right? Not now. Since your exam will be in.
I think class will start from August.
No,
Yeah.
September. Class start. I think September. It's a
No, actually exam is on September, so
That is
it
for
will take
reattempt
1
only.
month.
No.
exam is
Right,
a
but
October 9.
new term will start from September. So I think the person who joined probably he'll get a communications on WhatsApp or email.
Yeah.
It's coming.
But you are not in
September
right class.
15. After September 15, it will start for him.
Yeah.
The classes will start from September.
Yes.
Yes.
Okay. So sorry, I am in the wrong class.
Yeah, that's okay.
Okay.
Uh,
I'll leave.
yeah, as you wish. Okay, arrays of answer. Okay, going here and there. Let's see. Okay, 0.99. Okay, too much optimistic. That's okay. Yeah. So okay, previously. Okay. It's really related to previous question. Somebody is asking complement of choosing none of them red, right? So the complement that is choosing one red, 2 red or 3 red, right? So let's say choosing 4C1 plus 4C2 and 4C3, right? So this all cases are opposite of this, choosing none, or maybe choosing one or two or three, right? So that's why we only covered this, maybe, so that's a mistake.
Yes, sir.
We need to cover all three of them.
Remaining two.
Okay, and similarly here also we have so current question, if I talk about that, here they are asking what is the probability of at least one white ball. So they are saying that out of 6, one should come up, or 2 should come up, or 3 should come up, right? So all three of them white is also okay. So so this or, so you have to add that, that's clear, but finding this probability is you have to divide it by like 19C3. Okay, choosing 3, that's a sample, and this is also 19C3 and 19C. Okay, one important thing, is there any common thing in this? Like, common means, is there possible that I choose I've taken that case here and again here, a repeating case? Are there any repeating case? Because you know, right, A union B
There
A
is.
plus B minus A intersection B, right?
There is yes.
There is no case, right? There's no case. This is 0.
We are not.
Because see, here we are choosing one red, right? So one white. Let's say one white is there, and whatever it is. Here what's happening? We are taking 2 whites, and then whatever it is. So there is no way.
They will not be common.
Yeah, and basically this can't be white, right? That is the whole case. Like this can't be white. This can't be white. Here this also can't be white. So there is no common, right? So that's why we can add it without any problem. And basically this is the answer. You do this and answer. And another way is you can do 1 minus what? Probability of choosing no white balls, right? So
all white.
6C0.
Hello.
No white. Probability of one no white. Right? 1 minus probability of
Hello,
no
sir.
white.
That's what
13C3 divided by 19C3.
No,
Yeah.
that's what is asked. Probability of no white is asked. Oh, okay.
No, 1 minus
Okay.
13C3 divided by 19C3.
Who is this counting?
4 red balls,
Anand Kumar
9 black balls.
Upadhyay. Anand Kumar.
Yeah, why? Yeah, can you mute or okay. Yeah, hello.
Sir, I have a question, sir.
Yeah. Tell me.
Sir, it's necessary to give sir both cues who is the best student.
So, sorry, can you come again? Anand Kumar was asking. Hello. What was the question?
Hello.
Yeah. What was the question?
Sir, I already give choose 1 and it's necessary to give choose 2.
Choose 2.
Yes, sir.
Where in this
At least
question?
is given. At least.
Yeah, at least, right? At least one ball. Or at least one should be white. So, I mean, see,
Using this method.
I got
Sir,
one white.
I'm JBS student, sir, and I'm passing choose 1 also. But I'm not
He is
able to
asking
give.
about the terms. Is asking, not this question. It is general
Oh.
question.
Okay.
Yes. Yes, sir, it's general question.
You can ask at the end of the session or
Yeah, you can
without
please
question.
all those questions please end of the session. Okay, so now we're closing actually almost about to complete. Okay, so this is like you can do this way also, 1 minus probability of no
Sir, in
white.
this question,
yes,
using the previous method, sir, I don't know, like if I use the calculator, the answer is coming like very small. So could you please clarify what is the answer in this?
Can we put the numbers?
Okay.
1, 6,
So they are saying find at least one, right? So And let's say one white, which is okay. I think what I missed is 6C1 is that. Then you have to choose others from this thing, right? 13.
4C1
13
and
C2.
9C1.
13 C2, and then you have to do 19 C3. That is one white.
Oh, so
Then
that's why the numbers are so
yeah,
small.
then another is 6C2, and then out of 13 you choose one. And then in this case, you do 6C3, and all of them are here,
And
so 19C3. So this all you can add. Maybe this is, or you can do 1 minus probability of no white. No white. So no white is very easy. 1 minus, how many are there? 13.
13C3.
13C3 and divide by 19C3. You can do that. That is much easier. Okay, so at least if you get at least for something, it always go for the complement one. Okay. This is how 0.71 is the answer. Okay, let's move. Okay, Suresh applied for job. Okay, now the context is different. You can have time, 3 minutes.
Sir,
Yes.
எனக்கு எக்ஸ்ட்ரா ஆக்டிவிட்டில ஒரு டவுட் இருக்கு.
Okay, we'll take after this.
ஓகே சார்.
Sir, is the data correct?
Yes, it is.
This question has been last question, no?
Sorry, last.
This question.
No, there will be I think 1 or 2 more. So I think 25. We are at 25th slide.
Just a generic question, sir. Like here, the probability are very simple, right? Rejected or selected. Can we say that they are opposite to each other?
Yes, they are opposite. I mean,
So
1 minus.
if it is selected, then the negation is rejected, and if it is rejected, then it is select. A complement is selected. Right?
Yes.
Okay.
Yeah, math session next.
Yeah, we'll complete this. Okay. I think we'll have one more question and then.
Yes, thank you.
Okay, yeah, okay. I think we have passed this. So let me just explain this again. Let's go to this explanation. Here it is. So they're asking that what is the probability that he will get selected in one of the firm, right? So either A or B, and we write that with a union, right? P of A or B, something like that. So and then they're saying that of being him selected in firm X. So here X and Y is there. So the probability of him selected is the probability that he will be selected in one of the firms. So let's say probability of him getting selected X firm or Y firm is what need to find. And the given things are in X firm, if you want to get selected, that is like 0.7, right? P of X. Then I can do summation of P of Y, which is like given that rejected at Y, or and if I do opposite of this, so selection is 1 minus 0.5, so still it's a 0.5 only. Okay, but here I wrote about selection, complement of that. Then they say the probability of at least one of his application being rejected is 0.6. So at least one is getting rejected. So they haven't given like
So
what.
X intersection Y would be 0.4 from that.
Oh.
Yeah,
It's,
0.4.
no. What they are given is X complement
Union, intersection.
No.
No, union.
Union. X complement union.
Union Y complement.
Y complement.
See, we need X intersection Y, but that is not given to us. The given to us is
what they are giving is
that they get let's say the probability of at least one of his application being rejected is 0.6. So they are saying that
X complement.
Yes, or Y complement.
Yes, union Y
right?
complement is given.
It's given. This is 0.6. So from this I can say what I can say, P of X complement plus P of Y complement minus Y complement.
If you take a complement, it will become and.
Yeah, but and
I
is
guess it's De Morgan's law.
De Morgan's law.
If you take complement common, so it will get.
You get what you need.
Oh yeah, 1 minus I can do it, right?
Yes.
Yeah.
Yeah, I
That's
don't
why
need
I
to
said
go to that much. Correct. That's much better. Okay, so I can take so this is a complement of that, and I'll require end of this side. So that is like 1 minus 0.6. Okay?
That's
so that I will subtract from here.
That's
0.6, and that's what our answer. So this is like
0.4, not 6.
It will be 0.4.
1 minus 0. Yeah, 0.4. Okay. So this is like 12 minus 4, which is 0.8.
Very good candidate. He is getting a job.
Yeah, most likely.
80%.
I think the question should be selected in at least one of the firms, because it's union.
Yes,
it can happen that both selected.
Yes,
So
sir.
it should be at
Because
least one of the
both
firms.
events are mutually exclusive.
No,
No, it's not given
mutually.
like
He may
that.
get selected. He may not join.
Hello, sir.
Yeah, he can get selected both, right? That's not an issue.
Hello, sir.
Yes.
Sir, could you please repeat it once again? I didn't get anything. Please do it in
Uh,
step by step. Because
Sir, can you do it later? We have a
all
math
the
class
steps, so
after this.
everyone is telling the opinion. So kindly go with step by step approach, please, sir.
Okay.
Okay, sir.
See, give me 2 minutes. Okay. See, they've given that selection is P of A, right? 0.7. From the question, if you see that selected at form X is 0.7, right? So that's what P of A written here. Okay, this will make even more confusions. Okay. Let's say P of X. So selecting at form X is 0.7, correct? Then they said rejected at this. So rejection. In our case, we want selection only, right? So this what given is like kind of say you can say rejection, but I want how to get selected or something, right? So that is like you can say Y complement, which is like 1 minus 0.5. So that is again 0.5. This is also selection. This is also selection. Now to find if he gets selected either at X or at Y. That's what the question is. This is my from here I'm getting it. Probably that he will be selected in one of the form. Okay.
Sir, select in one of the firm means at least one firm, or
Selecting
because
one of the
X
firms.
union Y includes intersection also, right?
Yes. So either he gets selected at one A
Huh.
or B, right? So let's say this two Venn diagram are there, right? So either
Yes,
he gets
sir.
selected here or here. So basically all the things.
Okay, so at least one means either he will be selected in X or Y or in both.
Yeah, or both. Yes.
Okay.
Or
It is
both.
not mean that only in X or only in Y.
No,
Not
no.
in. Okay.
No,
So
both
union
is
means
there.
at least. Okay. Okay, sir.
Yeah, that's what we're counting that part twice. That's why we need to subtract one times. That's the idea. So okay, so that is P of X plus P of Y minus P of X intersection Y. Now this part is not known to us. I mean, but what is known to us is this rejected, right? So P of, they have given that P of X intersection Y complement. Complement is given, right? Which is 0.6. He's rejected X and Y or something you can say, right? So this is 0.6. What I need is this one. And you know from probability complement that PC plus P is 1. So from this I can say that 1 minus 0.6 is 0.4, which is this entity. Okay, so now it's the math part, that 0.7 P of X. Okay, you can erase this mark. Okay.
One small thing.
Yes.
From the wording to what we have concluded, I think the student should probably read a little more. The probability of at least one application is being rejected is 0.6. That is, they have to clearly understand the concept of a De Morgan. Yes.
Yeah. Okay. 0.7. This is 0.5, and I'm
Union
subtracting.
Basically, union of complements is equal to the complement of intersection.
I guess De Morgan's theorem is not in this week, right?
No, it's not necessary.
That's a set theory.
Morgan may not be discussed, but then that is, it's like a Newton probably didn't discover gravity. Doesn't mean gravity wasn't there. The concept is there.
Okay.
If you need to be clear, then yeah, it's a little bit extra. We have got to probably read and then understand and apply it here.
Okay.
The last line here, P of AUB is equal to 1 minus P of A complement intersection B complement. That's something every student should understand. Otherwise, you will get into trouble.
Okay. Let's move on to the next question. Okay, how many questions? I think this might be last. I'm not sure though. Okay, let's do this, and I'll give 3 minutes. Okay, I think 3 is too much, but that much I have to give, I think.
So this is without replacement.
So
Yes.
this with replacement.
I mean, we just have numbers. We just need to arrange them. Just without replacement.
So this repetition is allowed?
No.
Not allowed?
No, not allowed. So they are saying given 5 numbers, 2 alphabets, which are to be placed next to each other, right? So you just need to kind of arrange them. That's all you can do.
Oh, you mean the numbers are just
Yeah.
5 digits are given?
Yes. You have to just you can place them next to each other. That's all you can do, right? You can't.
We are talking about 7 characters being permanent.
Yes. And they are asking that there is exactly 2 numbers between the 2 alphabets. Okay, let's 11, but we'll closing, so I'll explain this. What we are doing is we have this 7 thing, right? 1 2 3 4 5 6, and that's a 7, right? So now they are asking that what is probably that there are exactly 2 numbers. So let's say this is number here, okay, some number out of 5, which is here, and then they are saying that between the 2 alphabets. So alphabets are only 2. We have only 2 alphabets. So let's say I have A and B. For general, I am taking A and B. Okay, these 2 alphabets are there, and then the later on, like anything, any numbers is okay, and 3 and 4 and 5. Okay, any number is fine. And how many different ways this can happen? So one way you can do is you can make this as a group. Okay, this is a group. So now let's say I have one group. This is group, and then 3 spaces, right, which can be occupied by numbers only. So this can be occupied by numbers only, right? Now in this group, okay, what's happening in the group? That's I have to show that numbers can appear here, right, only. So like let's say A B and B A. This 2 ways are possible. So that is like 2 factorial. Okay. Now this numbers can also swap, right? So n1 n2 is possible, and n2 n1 is also possible. So both cases are, so that is also 2 factorial. But the case is that we need to choose numbers also, right? So which number can come into this group? So how many ways to do this? That's a 5C2. So I'm choosing 2 numbers, arranging them, and then arranging 2 alphabets. You can take it like that. Then I have this 4 things, right? This 4, one group and 3 numbers. So how many ways to arrange them? That is 4 factorial. Yes. So and they are asking what is the probability of this. So how many total ways to arrange them? That is 7 factorial. Correct? 7 numbers are 5 plus 2, 7. So 7 factorial ways I can arrange all of them. But this way I can choose to arrange them, and 2 alphabets I can arrange, and all 4 of them also I can arrange. So this is the way you can solve it. And if you do that, this So 5c2 is 5 factorial by 2 factorial into 3 factorial. 5c2 is basically 15, right? 5 into 10, sorry, 10. Let me write that. So this is just 10, right? 5 into 4 divided by 2. Okay, this is 10. This 7 factorial. 7 factorial I can write 7 into 6 into 5. I divided with 4. So 5 here I'll divide. So that is 2. Now I have 2 into 2 into 2, 8. So basically 8 by
4 by 21.
77 into 6, 42.
4 by 21.
40. Yeah, 42, right? So that is 4 by 21. Okay, so this way you can solve this. Now the solution given is little bit different, but what they are saying is there are 2 alphabets and that can be arranged in 7c2 ways. Okay, same thing. So they're saying 7c2 ways we can arrange them. So that's how 42 came at bottom, and then we need to find what is at the top, right? So they're saying that we can arrange alphabets in 2 places, right? So let's say first and 4, 1 and 4, and then any number can come. So how many ways can we do that? That is 2 ways, right? Any number can come here and 2 numbers can swap with each other. So A and B can swap with each other, B and A. So that's a 2 way. Then numbers, I'll take first place, and so first and fourth is taken, and I'll take same thing with 2 and 5th. Again 2 ways you will get. Third and 6th, again 2 ways you will get. And then fourth and 7th place. So that is the last case. And you'll get, that's how 8 by 42. And same answer, right? 4 by 21. So either way you can solve it, whichever you prefer. I prefer the permutation way. Okay, yeah, okay, done. I think you can submit this part. What is your take on this? What's your understanding of concept of week 7 probability? Okay, I think I'm expecting at least 40, 50. And this is the last one. Okay, it's 45 hours already only there.
Sir, week 6 wasn't included in this.
No, but if you're gonna solve probability, then you'll require week 6, week 5.
So will there be separate sessions for them, or have they already happened, or
already
are there
happened?
Okay, so recordings are available for them, right, on YouTube?
Yes.
Thanks, sir.
Okay. Till
Thank
that,
you, sir.
yeah. So if nothing there, then this is the thing, right? So we can end this session. If any doubts are there, you can ask.
Sir, I have a doubt in extra activity.
Okay.
Actually, அதுல கொடுத்திருக்கிற lecture videoல
Sorry. I'm not
sorry.
Tamil
sorry.
or which
Okay.
language.
Actually, in the lecture video, they said we have to publish the site as an internal site of IIT Madras. The link should be like sites.google.com, onlinedegree.iitm.ac.in, and so on. But we didn't receive any roll number or login credentials.
So in
We are
that video explained, right, how to submit even though you don't have roll number, how to do that with your email ID.
Yes, but it shows only public. I didn't get anything for like IITM.
But that's okay. You can do it with your email ID, right?
Okay, sir.
Yeah, which is registered in this front, which basically you can, how do you access this course? Use that.
Using my personal ID, I can publish.
Personal ID, yes, but whichever you are using to access.
Excuse me,
this
sir.
course. Yes.
Oh, okay.
Yes.
Hello.
Yes. Yes. Go ahead. Yeah. Hello. I. Hello. What happened? Hello. Is there any? Okay. I think we. Okay. 19 students are saying that clear.
Excuse me, sir.
Yes.
So, in extra activity, how to do this second assignment?
Both are same, right? How you'll do first, that way you have to do second.
No, sir, not this one. In extra activities questions.
Yeah.
Weekly extra activity. Last one.
Yeah, last one, right? Weekly extra activity. Second one.
Yes, sir. So it's still confusing how to do this.
Have you watched any? So read this. No, you have to read this. That
I
PPT
already read.
given. So you have to do analysis. See, it's same description for 1 and 2. Okay, both of them. You have to create a Google site, which you can do very easily. Like you can go to this.
Yes, I admitted the student portfolio, but what the second one I do?
Yeah. Okay. So now
Tell about the use
they are
Google
asking
spread.
PK. You have to pick the data set, right? Somewhere of your interest. But it should have, so basically data set is required. That's all requirement is there, and it should have at least some rows. So we kept limit of 1,000 rows and 5 columns. At least that much should be there. And then the thing is, go to Google Sheet. Okay, Google Spreadsheet. You can take the data and do this analysis. So identify the following from your data set, that what it is, right? So categorical data. This variable is categorical, numerical. So what are scales of measurement? Ordinal. Not ordinal, but ratio scale, interval scale, or ordinal or num. Yes. So this you can do, and then discrete and continuous are they, and then you have to do some plots about that, right? Bar chart, pie chart, and all of them. Then you have to submit that thing in the Google site. How to do that? It's given in the video. You can watch the video.
So for the second activity, there is no video. Can you provide the video
Same
or
thing,
any link?
right? Same thing. For one, what you are doing, same thing you do for second one. Just another data set.
Okay, sir, I will try it.
Okay.
Thank you, sir.
Okay. Should we close now? Okay, so we'll closing this. Okay.
Hello, sir.
Yeah, hello.
Sir, I doubt in 3 question, activity question.
Okay. Which question? Activity? Which activity?
Week 7.
Week 7, 3, 7.
7.5, third.
Okay, 7.5. Third.
Yes, sir.
Okay, so they're saying Arjun wants to buy cricket bat and cricket ball. The probability of him buying this, the probability that he will buy a ball is this. The probability that he will buy both. What is the probability that he will buy either ball or so? So what is the issue with this? It's the classic case of additional rule. Very straightforward. Additional rule. P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, add this two, subtract this one. That's all.
Yes. And another question, sir. 7.6. Second question.
Second question.
Yes, sir.
Probability that the probability of selecting a red card or a 5 from a deck of this. Okay. How many ways to select red card?
26.
26 red are there, right? So
Yes.
26 ways. 26 card are there. So 26 by 52.
Yes.
That is of selecting red card. Then this is also classic case of additional rule. Then you select 5. How many ways to choose 5? 4. 4 are there, right?
Yes, sir.
So 4 and how many are common between them? How many red 4s are there? So red 5s are there, which are red also and 5 also. That you have to subtract, right? See, red, you find it. You find 5 also. How many 5s are there? And then you subtract which are both red and 5. And 5. Right? So this is 26. This is
26.
5.
2.
Actually, 4 cards are there. So basically, this is a card of 5. And then 2 are of this. So how many? What is the sum? 28. Divided by 52. Okay, this is the answer. So which case is it? 14 by 26 is there? No. 7 by 13. It's there. 7 by 13.
Yes, sir. And fourth, sir.
Addition rule. Okay. This is addition rule.
Yes. And another question, sir. Fourth.
Here. Here.
Yes, sir.
Particularly drawing a king and ace consecutively. Consecutively means you have to
pass me, sir.
You have to draw without replacement from deck. Okay, wait. Consecutive. When you're drawing a king and an ace consecutive from deck of without. Okay, with replacement. Replacement is consecutively. King. So king is 4 by 52. And then they're saying and 4 by 52 of ace. So this is like 8 by 52 square. Basically they are saying with replacement and like consecutive. So I'll take out a king. I'll first I'll do that. Then I'll put back the card again. Then I'll try again, right? So that time I won't ace. So to do that, this two other there is no common in between. So I'll just multiply them.
Multiplication rule apply.
Yes, because first this first thing and then second event, right?
Okay, sir.
8 by
Thank you, sir.
yes, yeah. So whatever this number is. think 1 by 13 into 1 by 13. So 1 by this one. Okay, anything else? Okay, then we can close this.